In this video, we will work on a problem about import quotas. So the setup is that we are given a demand and supply curve for domestic sugar, and we will first see what is the equilibrium price and quantity in autarky or no trade, and then we will allow for trade. We are also assuming that the world price of sugar is 24 cents. So if the domestic price of sugar is more than this, then we would be importing sugar. On the other hand, if the domestic price of sugar is less than 24 cents, then we will be exporting sugar. So let's first calculate the domestic price and quantity of sugar. In equilibrium, we want demand equals supply. We'll expect that the quantity demanded equals quantity supplied, which implies that 29.73 minus 0.19p equals minus 7.95 plus 0.66p. And now we can collect our p's on one side and the constants on the other side. If we do that, we get 0.85p equals 37.68. Want to calculate p, we get 37.68 divided by 0.85, which is 44.3. Or the domestic price of sugar is 44.3 cents. And if this is the price, we can then plug this price into any one of the equations and get the equilibrium quantity. So plugging this in our demand equation, we get our quantity demanded, which will also be the equilibrium quantity, equals 29.73 minus 0.19 times 44.3, and this equals 21.3. So this is our equilibrium quantity. So we are given that in no trade, our equilibrium price of sugar is 44.3 cents, and the equilibrium quantity is 21.3. So because the domestic equilibrium price exceeds the foreign price, we would be importing sugar. Now, in free trade, we can plug in the equilibrium price into our demand curve and see what is the demand. We can plug this into the supply curve and see what is the supply, and the difference will be the imports. However, let's say that this country imposes an import quota on how much sugar can be imported. And let's say that this quota is 6.9 billion pounds. So not more than 6.9 billion pounds of sugar can be imported. So imports are when the domestic demand exceeds domestic supply. So to find the import quotas, we can do domestic demand minus domestic supply. We say that this is equal to 6.9. Or we can now plug in our equations. We have 29.73 minus 0.19p. This is our domestic demand, minus our domestic supply is 7.95 plus 0.66p, and this equals 6.9. So we can now open the parentheses. We get 29.73 minus 0.19p plus 7.95 minus 0.66p equals 6.9. And this equation can help us find the equilibrium, the domestic price in the presence of import quotas. We can just rearrange terms again, move all the constants on one side and all the terms of p on the other side, and then we get 0.85p equals, we already saw that this plus this is 37.68, and then we can subtract 6.9, we get minus 6.9, or our p equals 36.2 cents. So we see that with the quotas, domestic price has not fallen all the way to the international price, but is somewhere in between the free trade international price and the domestic no trade price, which is 36.2. Now, suppose given this, the government is lobbied by the consumers to increase some of the sugar quota. So, in other words, allowing more sugar to come in. And now our sugar quotas have been expanded to 10 billion pounds. We can again figure out what is the price at which we would have a shortfall of demand minus supply equal to 10 billion pounds. So again, writing the equation, QD minus QS, this time equals 10. We get 29.73 minus 0.19p plus 7.95 minus 0.66p equals 10. So, and again, doing the math, we will get 0.85p equals, we saw 37.68. This time we'll subtract 10, which is 27.68. So this implies that our P is 27.68 divided by 0.85. And that is equal to 32.6 cents. So if we allow for more imports, we notice that the equilibrium price has now fallen from 36.2 to 32.6. Now the next question involves examining the effect of this on the producers and consumer surplus. So to do that, we can now draw a diagram. We don't have to know when the demand and supply curve originate, but based on the numbers that we have, that 24 cents is the free trade price, and that in the initial quota regime, our price is 36.2, and with the new quota regime, our price is 32.6. So these will give us the price points. Then we can actually find the domestic demand and supply by plugging in any one of those. So let's say that we plug 32.6 into our demand curve. We can subtract 10 from it. We will get our quantity supplied. Similarly, we can plug in 36.2 into our demand curve. And once we subtract 6.9 from it, we can get the domestic quantity supplied of sugar. To illustrate the domestic demand and supply at each of these import regimes, our demand curve is given by 29.73 minus 0.19p. And we've established that in the initial regime, the free trade or the domestic price of sugar was 36.2. We can plug this in. So we get QD equals 29.73 minus 0.19 times 36.2. And this will give us that our QD is 22.8. And then by default, QS we know will be 6.7 billion pounds less than this, which will be 15.9. Similarly, we can establish that when our domestic price is 32.6, QD will be 23.6, and QS will be 10 units less, or 10 billion pounds less than this, which will be 13.6. So these 2 points give us the demand and supply at 32.6, whereas these 2 points give us the demand and supply respectively at 36.2. And we can now translate these points into our graph. So we have our price and quantity axes. The way we've drawn this, price is in cents and our quantity is in billions of pounds. Right? So our demand curve, again, we do not need to know when the demand curve starts. Same with the supply curve. Let's say this was the equilibrium price. And suppose this is 24 cents or the free trade price. Where the question begins is that initially the regime allowed only 6.9 billion pounds of imports of sugar. So let's do that, and then we were told that the domestic price was 36.2 cents. At 36.2 cents, we were supplying 15.9 billion pounds of sugar, and we were demanding 22.8 billion pounds of sugar. And the difference was 6.9, which was our import quota. When we allow for imports to increase, that essentially means that we are letting the domestic price be a little lower, 32.6. Now at this price, domestic supply will decrease even more because price has dropped, and this falls to 13.6 billion pounds. But on the other hand, because now price is lower, domestic demand goes up to 23.6. And this gap is also 10. We can start analysis by labeling the areas. We have A, B, C, D, and then we have E, F, and G. So with the expansion of quotas, our consumer surplus, which initially was this top triangle, now increases to this big triangle. So essentially the difference is the areas C, A, B, C, and D. So our change in consumer surplus is areas A, B, C, and D. Now what's neat about this graph is that because we're given the quantities and the price, we can actually calculate these areas A, B, C, and D in dollars. So A is nothing but a combination of this rectangle and this small triangle. So we can look at A as the difference between the two prices, which is 36.2 minus 32.6 times the base of the rectangle, which is 13.6. And then we have this small upper triangle whose base is the difference between 15.9 and 13.6, and the height is the difference between the two prices. So we can add that to 0.5 times the base, which we said is difference between 15.9 minus 13.6 times height, which is 36.2 minus 32.6. And this number will be equal to 53.10. So again, notice this is 53.10 billion cents, or in dollar amounts, this is $531. Similarly, we can look at area B, which is the small triangle. It's given by 0.5 times space, 36.2 minus 32.6 times our height, which is 15.9 minus 13.6. And this equals 4.14. Sorry, $1 million. We can look at C as the rectangle, and C is also given as 22.8 minus 15.9. And again, this gap is 6.9 times the price differences, which is 36.2 minus 32.6. And this area is equal to 24.84. Finally, D, which is this triangle to the right, equals 0.5 times 23.6 minus 22.8 times 36.2 minus 32.6, which is 1.44. So our total consumer surplus is the area A plus B plus C plus D, which is 531 million plus 1.4 million plus 248 million plus 14.4 million. So the change in consumer surplus, which is A plus B plus C plus D, now equals 800, which is 83.52, which is $835.2 million. On the other hand, the change in consumer or producer surplus is just, as we said, the trapezoid A, which we calculated to be equal to 531. So while domestic consumers gain $835 million, domestic producers, when we increase import quotas or allow for more sugar to come in, have their welfare go down by $531 million. Yes, one gains, one loses, but the net gain in this case is still positive.